Hi students, welcome to S&M Coaching Center. We are continuing with the real number solution series and today's question is proving root 2 as an irrational number. This is a compulsory question for both the CBSE and the Karnataka State 10th board exams. So let us directly go to the solution. They are asking us to prove root 2 as an irrational number. Now, whenever we come across such sums, what we have to do? We have to argue in the contrary. What do you mean by argue in the contrary? They are asking us to prove that it is an irrational number. We say it is a rational number. So, the first sentence has to be, let us assume root 2 is a rational number. What is that we will say? We have to assume the root. It is a rational number. When we say root 2 is a rational number, which means root 2 is equals to a by b form, and you know a rational number is always represented in the form of a by b. Now write conditions for a by b. What are the conditions for a rational number? A and b, they should belong to integers, and then the denominator should not be equals to 0. B should not be equals to 0, and the all important condition, A and B should be co-prime. Solve it. So square it on both the sides. Square this equation on both the sides. Square on both sides. When you square on both sides, what is that you will get? You should show each and every step you have to show. When you square it on both sides, the square and the square root, they get cancelled and you are left with 2 is equals to a square by b square. Now do the cross multiplication. 2b square is equals to a. And one more next important step. Bring 2 to this side. B square is equals to a square by 2. Now, what is the meaning of this a square by 2? It means that the square of a number a is divisible by 2, which means 2 divides a square. Therefore, 2 divides, what is the meaning of this? It means that 2 divides a square. And we have a theorem which says that if the square of a number is divisible by a prime number, then the number itself is divisible by the prime number. Now the square of a number is divisible by 2, that implies 2 divides a. 2 divides a. This is your equation 1. Write it down. Suppose, now what is that I am saying? A is a number which is divisible by 2. A is a number which is divisible by 2. Therefore, how can we rewrite A as? A is a number which is divisible by 2. So, A can be written as 2C. Why did I write like this? Because I know A is divisible by 2, which means A is equals to 2C. Now, square it on both the sides. Again, you have to square it on both the sides. SBS means square on both the sides. When you square on both the sides, you get a square is equals to 4c square. But what is a square? A square, I know it is already 2b square. So I will rewrite this as, in place of a square, I will substitute 2b square. So a square is nothing but 2b square is equals to 4c square. Continue. 2 ones, 2 2s. So what am I left with? B square is equals to 2c square, which implies get 2 to the other side. C square is equals to b square by 2. C square is equals to b square by 2. What is the meaning of this? C square is equals to b square by 2, which means, that means 2 divides b square. 2 divides b square. And what did I tell? If the square of a number is divisible by 2, then the number itself is divisible by 2. Therefore, 2 divides b. Therefore, 2 divides b. Make it as equation 2. Now from equations 1 and 2, from 1 and 2, what is that you are getting? 1 and 2, what is that we are getting? 2 divides both A and B. 2 divides A, 2 divides B. So what can we write? We can write that 2 divides both A and B. But what did we assume to A and B to be? We assumed A and B to be co-primes. But A and B are what? A and B are co-primes. On one hand, we are saying there is a common factor 2 for A and B, and we know that they do not have a common factor because that's how we assumed them to be co-primes. Now, what is happening? There is a contradiction that is occurring. This contradiction occurs. Why is that contradiction occurring? This contradiction occurs because of our assumption this contradiction occurs because of our assumption that A by B. This contradiction occurs because of our assumption that root 2 is a rational number. Therefore, our assumption is wrong. Our assumption is wrong. If our assumption that root 2 is a rational number is wrong, then what is the correct statement? That root 2 is an irrational number. Hence, root 2 is an irrational number. Is an irrational number.